Okay, all right. Welcome to the lecture 3, session 1. Am I audible? Can anybody please write yes? Am I audible? Am I audible? Mm, okay, thank you very much. Great. So, thank you very much for writing yes, and let me continue. So this time we are going to continue the lecture 3, and last time we have studied about some of the models which are actually we can use into the artificial intelligence system when we are going to make the agents. So we would start from the last brief review that what we have done in the last class, and then we would continue. Okay. Okay. All right. So this is the first slide. Then today we want to, in the last class we have discussed these things. Number one thing was this, that AI attempts to build intelligent agents that we know, and these agents are actually mostly rational. And we have discussed in the last class that by rationality we mean that if there is some information, the system would be using that information only to provide the output. And if the information gives you something, then the system would take only that decision. Okay, if it is told to something told to the system would only take that decision which comes out of the information. It would not take anything else from the from outside, and it cannot take anything decision that would not be contrary to the whatever the data has been shown. Okay, sometime let's assume that the agent is a judge, then given all the facts he would take the right decision for the particular case. So he would not take any negative decision. Means negative means maybe criminal may be leaved, or the non-criminal can be given some sentence. Both the cases could be there. So I just say that in whenever we are talking the rationality, we don't mean that humans are not rational. Humans could not also be rational, but rational agent means that it only depends upon the data. It does not have anything else. Okay, and please note down that the rationality is not the perfection, because rationality depends upon the shown data, that the data that you have. You don't have all the data, okay, because if you have all the data, then you can take the perfect decision, but you cannot take the perfect decision because you are only taking decision based on the available data. So therefore rationality is an important concept, and the perfection, it is not the perfection. Okay, so how to build those systems? Most of the time we think that in what situation what action should be taken. If we write all those things, then we can build such an agent. Okay, so this method is called, the most of the time, it's a tabulation method, but it is not possible because the number of possibilities which can be in front of the agent could be very large when we are talking about a practical agent. If it is a toy example, then we can restrict that how much is shown to the things, and how much if it is a synthetic environment, we can also control that what are the challenges that are shown to the agent. Therefore then we can say that our transition table is going to be small, then we can write, otherwise it is not possible. You would agree with that. Also we have seen that in case we want to build a system, so how we are going to specify our system, because there are some parameters, and if we change the parameter, we need to have the different kind of logic. So we have seen that to fully describe the system, we need the performance, environment, actuator, and sensors. Okay, so there is an acronym called PEAS. So P for performance. You divide some of the criteria. Based on that, you say that okay, how good you are, because ultimately only doing the thing is not important nowadays. Everybody thinks that if you are doing a course, you should be getting the higher marks. So it is called as a performance. If what is environment? Environment means whenever the system is working into the some area, the environment plays an important role, because and there would be some properties of environment. We are going to shortly discuss into the next bullet point. So environment could be various kind, such as it is whether it is a fully observable, means you can, if you know everything about the system, and therefore you can take the perfect decision. But most of the time, fully observable things are not there. And for example, even if you deploy a camera to somewhere, the camera can see whatever is in front of the camera. You cannot see what is backside. Sometimes it may be possible that you can apply the fourth, the multi-directional camera, but then also it would not be able to see the place where it has been mounted. So something would be there that into the real life scenario you cannot find out any fully observable system, and similarly most of the time your system is partially observable. So we are thinking these properties of the environment, and there could be the single agent versus multi-agent. So it may be possible in one environment only one agent is there, or if multiple agents are there. If multiple agents are there, then there comes the question that whether they are going to collaborate or they are going to have a competition. If they are going to collaborate, so they can solve a bigger problem. If they are doing the competition, they may be improving themselves. So you have to understand that whether more agents are there into the system or not. Similarly, deterministic where stochastic. So in the deterministic system, whenever you say that I'm into this state, I take this action, I'm going to be into this particular next state. But into the stochastic, it is a probabilistic only. It says that with some probability you are going to be into this state, with another probability you are going to be into another state. So therefore, you are not sure that what is going to happen when you are going to take this particular action. So most of the time, each will realize its scenarios. Things are stochastic. Episodic versus sequential means so we have discussed this also. Means episodic means. Sometimes what happens that whenever you perform some task, you can divide into parts and say that this particular part is repeating one by one. Okay, that part you can say means 4 or 5 actions. You can say that it's an episode. So when you are standing over this particular, your robot is at some particular logical point, it can execute some episode to do something, and then it can perform another operation. And sometimes it is not possible. Every step is different. You cannot say that there is some pattern, means you can find out some pattern that is need to be followed, and therefore it is a sequential environment. So these are the properties. Static versus dynamic. In the static environment, everything is fixed, and now you are performing your moves, such as a chess is a static environment. But in the dynamic environment, such as when you are developing a moving car, okay, then it's a dynamic environment. You cannot say that where are other cars. Other cars would be they are not static; they would be moving. So your environment itself is changing, and therefore giving you the more challenge into your designing phase. Discrete versus continuous. I think everybody knows this. That here in the continuous, look, can anybody tell me that whether the discrete system are better or the continuous systems? Okay, can anybody tell? Look, why I'm asking this question is that nowadays people are using discrete system most of the time. You say digital computer, digital was, people are talking like this. These are the discrete systems. What are the continuous system? The continuous system is a clock that doesn't stop and keeps rotating. Discrete, tick, 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 it is moving. So you see that the continuous things are better, because whenever you want to measure that what is happening at particular moment, there will be some place where the clock is there, so that you can find out the sense of time at every moment. But in the discrete you cannot find, because at some time it is a 1 minute, then another minute, then next after 1 second it would go to the next second. So you cannot find out the time in between. But what is the issue? That the issue is that every system is subjected to some noise. And because of the noise, when the continuous system are affected by the noise, there is no way to measure that or to identify that the system has any kind of errors. So therefore, that error is actually included directly into the reading. Whereas in the discrete system, we know that if I say that I am going to send some signal from A to B, and only I'm saying that signal is going to be 5 volt or 0 volt. If somebody give me the signal of 5.5 volt, what would happen? I would say that no, it's not 5.5, it's 5. So these kind of error correction are very easy. But if it has been a continuous system, person was also allowed to send 5.5, then I had no way to say that there was a corruption happened. So in my what I want to convey is that the continuous systems are better. But the problem is that they are not much they are not much error prone. They are much error prone. Therefore, that we go for the discrete system so that we have a better system, better accurate system. Okay. And there could be known and unknown system. Can anybody know that what is the unknown and known system environment? Okay, this is again a very important thing. For example, if some spy is being sent to the some place, okay, so and he have to send you some information, then it may be possible that the complete system is not known to you. He have to discover all those things, that what is going to happen. So in that sense, we say that the system is known or unknown. Okay. So in this PEAS, the second thing was environment. Then we talk about the actuators. Means whenever you want to take the decision or actions, what are the things that you have that you can apply? Such as you can have a motor and you can start that motor or switch off that motor. And similarly, you can inject something, you can do something. So those are the actuators. And then we talk about the sensor, such as a camera that can take the photograph, the things which are actually giving inputs to this environment agent. So using these four things, we can describe any agent, any intelligent system, an intelligent entity. And then also we have discussed in the last class that when we are going to develop an agent can be of the four type. Okay, and we have discussed very in detail into the last class, but I would just tell a small outline that what is the simplest reflex. This is the most basic one, that it says that whenever this kind of sensor input is coming, you take this action. It only takes the decision based on what is coming from the sensors. Okay. So something he is saying, he is taking some distance. A simple reflex, best system, very fast system. And whenever we are making very complex system, we want simply reflex to be there. You assume now, for example, we assume that you are a person. Okay. Sometime you see that there is some blast. Okay. There is some amaj hua, blast hua. Then what happens? You just quickly go away from that place. Okay. You see that sometime somebody, some spy, assume that there is some fly. It is coming very near to your eyes. Your eyes would shut down. You would close your eyes. So why it is happening? Is it possible that if your brain is going to process those things and try to see that what is the speed of this particular thing, whether should I change my move my head or should I close my eyes? So these things cannot be applied because systems which are actually doing processing, they take time. So sometimes we want to build a system that don't take much time, they don't take processing, just given the input, take some output. So these kind of very basic systems, simple reflex. When you are developing a automatic vehicle, you put some of the components over there so that when you see that there is a red light and it is very near, then you stop the car. So this is out of the logic, most of the thing. If you can build a complete system based on that, one thing is that you build complete system based on the simple reflex. Those systems would be very fast. But sometimes even if you cannot make, because there is a limitation with the simple reflex, because they can only perform very simple kind of very elementary kind of operations. So therefore, simple reflex are very efficient and very important model, but for the complex tasks they cannot perform. Okay. Then it comes to the model based system that tells that first he would analyze that what is my state, and then based on the state and based on the input that it is going to get, it is going to take some decision. For example, when you are let's assume that you are driving a bicycle. Okay, you are an agent, you are driving a bicycle. Then what is the simple reflex? How to move the bicycle. Okay? And what is the model base? Model base says that when you see that somebody is coming, then you move around here and there. Then what is happening over there? What is my state? Whether I am on the road or not. Then if a car is coming, then you come down from the road. No car is there. You come in between the road and walk. So these kind of things, because you see what is your state and then you move your cycle. So here next thing came. What was this? That awareness of the environment, and then using that environment and the state, you can ride the bicycle into the better way. Then comes the goal based. Okay. And goal based says that okay, you are driving the bicycle, but why you are driving the bicycle? Okay, is it just for enjoyment, or because you want to go from some place to another? If you want to go for some place to another, then again a different thing comes into your mind, that what should be the right way to go. So you would take a particular path. So now your planning is required for you. So these kind of things actually are the goal-based system, where the system is not only running, not only aware of the what is its state, but it also has some goal. Therefore, it solves some of the problem out of that, and then he has the solution, and then he goes out for that solution. You understand? And then comes the utility-based system, which is actually a better version of the goal-based system, which actually tells that okay, I want to go from place A to B, but and you have find out that this is the path to go from A to B, but it may be possible that other paths are also possible. Then which of them is best? This feeling, when you introduce into the system, it is a utility-based system. So here there is some performance measure that you want to optimize. So can you differentiate now between these four things? So once again, I just want to stick to this particular simple example. That simple reflex model tells you that how to ride the bicycle. Model-based system says that you should be aware that where you are, and then based on that, if there is road is vacant, then you can go in between and ride. If some vehicle is coming, then you take something. So model-based system are better, because simple reflex system can only take the action that what should I do, then they can we frequently have some problem. But model-based system are better because they know what is my status. But the model-based system are just maintaining the system. You see, there is no goal. If there is a goal, for example, I tell you you have to go from A to B, then you go for the goal-based system. And then comes the utility-based system, which tells that if you are going from, okay, you have a goal, you are riding a bicycle, then this, but even then, this particular way is going to be better. Okay, so these are the four basic kind of agents that we have, and then we have also talked about the general learning agent. That means if you want to develop a system that by itself can learn, it is then this also have to include three important parameters based on this complete thing. Let's assume that. Look, what I want to say that all these models, means even if it's a simplex model, model-based, goal-based, or utility-based, they are actually working. So there is some underlying logic. How to modify that logic? So this is called learning. Okay, if you can improve, because as the time goes, with the respect to the time, if you can make the system better, then it is then it is a good learning system. So in case you want to build a general learning agent, means as the time passes by, your agent is learning, then you need three more components. One is the critic, component that takes that what is the performance parameter and how this agent is behaving, and then based on that it provide feedback that at least you should tune these parameters. And then comes the learning agent, because he knows that if this kind of feedback is given to me, and these are because learning agent knows that what are the underlying parameters of all the systems. So he knows that these are the parameters. Critic is telling me that I should adjust in this way, then he modifies the parameters so that system becomes better. Now the system has become better, but to learn that in a particular way, he have to need to perform some of the experiments so that it can tell that okay, no, I am right. Okay, so those scenarios are given by the problem generator. So therefore, problem generator is a kind of testing, because if you don't test the system, your system is going to be, you cannot say that my system is going to be better. So therefore, problem generator gives various scenario. In those scenario, new things that has been developed by the learning agent are actually tested, and then we say that my system is better. So this is the overall the general learning model we have seen in the last class. So we are in this class we would also see that very important thing that is called the problem solving agent. Okay, so problem solving agent means there is some problem, and that particular problem is actually my agent is going to solve. This is the very basic understanding. Okay, so so we have seen this thing in the previous. We have discussed this thing that the reflex agent cannot operate well because when it needs for the planning, if there is a planning involved, then the reflex agent we have seen that the reflex only take the decision based on what is coming to me, so therefore it cannot do the planning. The scenarios when the large table is required, then it is also not going to work, because when the table is large, just given some condition to find out the appropriate action, it have to search through the table, and that would take a lot of time. So then it becomes bad. Okay, so most of the time we want to go for a goal-based agent, and we are going to concentrate on this in today's rest of the class, that we are going to talk about the goal-based agent. So whenever in the next session I'm going to talk about the agent, it is actually problem-solving agent, and that is a goal-based system. Okay. So we know this, that it uses a state of the word, because what is the state? It knows. And how to describe that? What is the state of the word? That is not an easy task. Let me tell you, that is not an easy task. Most of the time, if you want to describe complete thing, it is not being easy. For example, if I want to say that what is the status of the bits. Okay, if I say your organization, if I want to say that what is the state of your organization, it would be very difficult to specify if you go at very high level, very low level detail, such as you say that whether there is a guard standing in front of the building or not, whether Mr. X is sitting on his chair or not, Mr. Y is sitting on his chair or not, whether the meeting has been conducted, everything happened or not. So you can find out these parameters, and based on that parameter you say that I'm going to specify that what is the state of my company. But this you cannot do, because so many parameters are involved. Measuring them and explaining them going to be very difficult. So you can do an abstraction. Let me just give you an example. In abstract way, you can say whether your office is open or closed. Okay, so in this way, very simply you can define, because now you are not considering many concepts. You are only considering two concepts only, that whether it's open or closed. So look, very easily you can define the states. So similarly, whenever you want to define or tell the state of a particular problem, you have to find out some cumulative sense. Okay, very abstractions. You have to find out some abstraction, and you have to define that thing into the cumulative way. Okay, so I think you understand this, that whenever you want to define the states, because you now into the goal-based system, you need to understand what is the state, and then how to define the state. You can define some abstractions, and that depends upon the problem. But you should know that you should not go very detailed into the system. Okay. Now it is a very important part that two kind of search you can apply. One is called the uninformed search. Here, uninformed search is actually we are most interested in, because we don't want to provide any information and let the systems by itself provide to you the right answers. But whenever we develop those kind of systems, they are actually limited and limited with the performance, and the system which are actually provided some cues, they are better. Okay, because ultimately the performance, because although we can develop these kind of uninformed system, but their performance, if their performance is lesser, then we have to think that it would be better that if you can use something else so that your performance is better, because the performance measure is a concern of being intelligent. If somebody is more intelligent, his performance would be better. You cannot say that the person who is failed is more intelligent than the person who has actually getting more marks. In terms of only marks, if I'm only considering on this is only the fact. Okay, if you consider more dimension, then okay, you can expand, because now your change of the states is changed. Okay, but if you are here, then based on some parameter, you can say like this. So I'm bringing an example that is from the book only. Consider an agent enjoying a holiday in Arad, Romania. The Romania is a country where there is a place Arad. So my agent is actually enjoying the holiday. So what would be the efficiency? How would you find out that what is the performance measure? How would you say that whether my agent is more efficient or not? So you have to define some parameter measure. So parameters could be that he want to improve his suntan, he want to improve his color. Okay, he want to improve Romanian language. He want to see more sites. So these could be the measures that he want to. If there are two agents, then you would try to compare that which agent is better. So you would try to see that there would be some parameters. Okay, so let me tweak something, and let me see that what if he has a flight from Bucharest next week. If he have a flight from Bucharest next week, then what is going to happen? Then the agent would be good because if he reaches that particular place, because if he doesn't reach Bucharest to catch the flight, then the agent is bad. Okay, he is enjoying the holiday, but if he reaches Bucharest at the right time, then he would be a good agent. Otherwise, he would not be a good agent. Is it? Are you with me? What if uh, I'm talking about an agent that is enjoying a holiday in Arad? There could be various performance measures, but if I introduce one more parameter that he has a flight from Bucharest next week, then he is only good if he can get the flight. If he miss the flight, then he would not be good. So he must adopt the goal of getting Bucharest in the time. Is it clear? So here comes the sense of some priority. Okay, it gives you the some sense of priority. Okay, so you should understand that when let's only talk about talk about this particular agent only, that how this agent is actually how this agent state we can define. So since he is visiting in a country Romania, so we can say that in which state it is. That would be the state itself, because which place it is, that would itself can be state. So being in Arad is one state. Similarly, you can find out other states. And what is the goal? So the goal would be also some state, because lot of states are there. The goal state would be another state, and the system is right now system is not into the goal state. So therefore, he want to come do something so that he can come to the goal state. Is it clear? And the agent task is, because agent is solving some intelligent problem. So what is the task he has? He has a task that he want to find out how to act, how to take some actions. Okay, how to take some action now, what action he should take now, and what action he should take in future, because he also have to do the future planning. If he going only into the greedy way, he may stuck into the some problem. So he should know that how should I take the action now, and what should be my action into the future, so that I can get to the goal state. And again, I want to talk, as we had talked about, that the state should be abstracted. Similarly, the action should also be abstracted. Okay, you cannot tell such as if he want to go for A to B. So, for example, if the action should be go from city A to city B. If you start developing the concepts such as move 5 kilometer into this road and take a left turn and go this way, right way, then it would be very difficult for you to specify all those things. Okay, because those things can be taken care of the another system. Whenever you are solving a big problem, you want to reduce the problem, so that when the dimensionality is reduced, you can solve the problem efficiently. Then you go inside and solve that particular part. Are you with me? So you should, whenever given a problem, a lot of options are there. So you should only see from some abstraction level and solve that problem, and then you dig inside and then solve the individual compartments. It should be a top-down approach to solve the particular problem. You should not say you should not specify to go from A to B all the moves, such as go get into the car, switch on the car, go and start rotate the steering 10 degree left and right degree to 5 degree right. Then that is not going to work, because if you are going to define into this detail, then there are a lot of uncertainty into the system. It may be possible that something else happens that you don't know. So at this very high level, if you try to address that thing, you would not be able to address that. But if you can specify go from point A to point B, then in between how to solve those things you can solve. Okay, So agent task is to find out how to act, and these actions should also be very abstract level. For example, in our here I want to focus that whenever a person, whenever an agent want to solve a particular problem, he should consider that what action he should take at this moment and what action he is going to take into the future. Both the things he need to take the consideration. Okay. For example, let's assume that in our example where agent want to go to the Bucharest, and here let that there are 3 roads out of the Arad, because he is in Arad. So there are 3 roads. Okay, one towards the Cebu, and one to Timisoara, Timisoara, and one to Jerind. Okay, I'm sorry for the wrong pronunciation, but let's assume that there are 3 roads coming out of the Arad. One goes to Cebu, and another goes to the Timisoara, and the third one goes to the Zerind. So which road he should take? My agent should take? No idea, na? We don't have any idea, because none of them achieves the goal. If anybody of them has been the goal state, then we know that for sure we should take this. But we don't have any information. We don't know this. So what more information is needed? Please try to understand this particular small part, that sometime only current, because if we want to take only decision based on what is shown to me right now, then this is going to be a problem, because right now I cannot take the decision. But if I also consider what is going to happen into the future, for example, when I take the road to the Cebu, what is going to happen there? If I go to take the road to the Timisoara, then what is going to happen after that? If I also consider those things, then only I can take the right decision at this particular place. Okay, this is therefore I want to once again highlight that the agent need not to only think that what decision I should take at this moment. Also, he have to think that what decision I should take into the future. So okay, so he needs some familiarity with the geography. If he knows some geography, then he can of Romania, then he can understand. And this is what the geography of Romania is his environment. Okay, he want to find out some understanding of the environment, and you know that in case of this particular example, a map can specify this environment. If you specify a map, then things are there. Okay, so here in our case, our environment is observable because agent knows that what is his current state. He knows because this observation he have. It is discrete because agent knows that what are the action that he have to take, and there are finite many number of instructions. These things are discrete, and environment is known also because he knows that if I go from if I take this particular action, then what is the next state? What agent knows that which action to take to go for this state to this state. Therefore, everything is known. It is deterministic because the location of the cities is not going to change. Okay. So what is the solution? What is the solution? If I provide the map, what is the solution? The solution is to the problem correspond to the fixed sequence of action, because somebody can specify that these are the action to be taken, then my problem would be solved. Okay. Okay. So now if I specify you that take this map and give me that I want to go for Arad to Bucharest. Okay. So give me the solution. Then how would you find out that? How would you find out that given the map? You look, don't answer by yourself because you know that how to do this. But in terms of the algorithm, how would you write that algorithm is an important question. Okay, so many other time we do so many things, but we are not able to explain in terms of the algorithms. So here you should understand that this is a problem given to me. If I give this map to the system, how the system is going to solve this. So now this is the algorithm. This is the question asking that what is the algorithm, which algorithm you are going to use. This is an important thing. You understand this? So okay, given the map, how to find out the solution is the thing. Okay. So and if you know this, then at the end you have to come up with a sequence of actions that you should take to reach the goal goal state. And what are the action in case of our things? Action is go from city A to B, go from city B to D, D to X, X to M. So you specify those kind of things, and those things are actually my answer, search output of the search. Okay, so here search is a different thing. Search is in the earlier things. What were the search? Search was that given a list of, if you have an array, you want to find out an item, you go and search for that item. This is not the same search. This is a different search. Here you want to search for the strategy. What should be the strategy? And where is the strategy? Nobody knows where it is written. So this search is very different. That I want to highlight over here, that this search is different because I have given you the map and I am going to ask you the question answer. Okay, that I want to go from A to B. What is the route? So where is the route? The actual answer is not written somewhere. You have to by yourself construct something. You have to do something. You have to apply some algorithm to come up with the answer. In the general search thing, an array is given to you, and now you have to find out that whether the item is there or not. Here also the item is not specified. Okay, we have only specified the environment to you, and in that environment you have to find out the solution. Okay. Okay, so I think you understood this. Then we should see that if you want to solve this problem, any problem, then you have to properly define that problem. Okay, so if a problem is given to you, how to define that problem? That is the first thing. First you define that problem, then you solve that particular problem. How to define that problem? These 5 things need to be used to define the components. Okay. So these 5 things you need to tell. Okay, what are these 5 things? Well, the first thing is the initial state, because the environment is given to you. If environment is specified to you, you have to specify that which is the initial state. So here in this example, let us have a function that is called in function. If I give you in arad, so it would give you true that you are there, otherwise not. So how to find out the initial state? It gives you that in arad means you are into the arad, and then you initial state, for the initial state somebody specified that this here from you have to start from the arad. The in arad is true, all other places is false, not anywhere else. Then the second thing that you have to specify that what actions you can take, because when you are in arad, then you see that what action you can take. Action would be different. If you are into the different state, the available action would be different. So in arad you can go directly to the Subu, in Timisora, Gerind, but if you are into the Timisora, you cannot go to the may not be able to go to the Subu or Gerind directly. It may be possible that there is no direct road, but you can go to the arad for sure. But sometimes it may also be possible that there is no way to go here, because let's assume that it's not the highway, it's only flights that are direct flights are available. If direct flight from Arad to Timosora is there, but no flight from Timosora to Arad, it may also be possible. So similarly, you at every state you have some actions. So you define that. Second thing that you have to specify when you are going to specify a problem is what are the actions. Third thing, transition models. Okay. And the transition model says that when you are into this state and you go take this particular action, go Gerin, and if you are into the in arad and you take the go Gerin action, then what is the result? That you are in Gerin. This is what the output. So similarly, you can. This is a pseudo code actually, and what is the code difference between code and pseudo code? Let me just tell you that in the pseudo code is written in the English language, and where you can follow some of the syntax from some of the languages, but it is not required. You can only single English language you can specify that you step by step you specify something that you do this step, then this step, then this step, then it is called the pseudocode. So similarly, this also is a pseudocode. So result that you obtain when you are inside the arad and you go Zerin is that you are inside the Zerin. I have a question: is transaction model is pseudocode? Pseudocode is an algorithm. Okay, transaction model. What do you mean by transaction model? Transaction model is not the code actually. Transaction model you have to specify. So I was telling that the language that I'm going to use looks like a pseudocode. Okay, that part only I'm telling. Transaction model is not the pseudocode; it's a table. Okay, because in very you know that whenever transition model is very important thing, because you are going to take the decision over here, na? It is in terms of the table. You can realize in terms of the table, and most of the time if it is a function and you can divide the function in some way, then even the table designing the table is not required. For example, if I make the table that I'm writing the numbers x and I'm telling the next number, so I can make a table that I can write all the numbers and I can write all the next numbers to that. But I can write the function also. The function, next function is x is equal to next function of x is equal to x plus 1. Then I need not to specify this table. Only single line would suffice. Similarly, transition model is a function, and it's not a it's a function or table, and I don't know what should I say that, because when it is a function, it could also be a algorithm. So in that sense, it could be a pseudocode. So I don't know what should I say, but in that sense, please understand that transition model represents a table, and that can be represented by a function. Every function is a algorithm, and therefore you are right that transition model can be specified using the algorithms. Okay, are you with me? Is it clear? System would determine the result, or we need to provide the transition model. The question is system would determine the results, or we need to provide the transitional model. Very interesting question. Look, in the reflex systems, we have to decide by ourselves that what is going to be the next thing. But if it is a learning system, it can based on the input output, it can by itself configure itself so that it would show that particular output of the function, even if the function is not specified. So it depends upon the answer to this question, that how to specify whether we should specify the transition model or the system would by itself do, depends upon how the system has been built. If it is a learning model, it can build the transition model based on it. Otherwise, we have to specify. And if we are going to start specifying the things, we would not be able to decide, make a very good system, because we have the limitation. We can only specify few things. Now the fourth thing that you have to specify is the goal test. Means you have to specify that how to test that this particular system is into the real state or not. Okay, you have to specify goal states can be more than one. And here, since the flight is from the Bucharest, then it is Bucharest. Then only one goal state we have. Otherwise, multiple goal states are possible. And then path cost, you have to specify for everything that what is the cost that it is going to have. So the problem solving agent actually try to go for this particular algorithm, and this is a very simple algorithm that the problem solving agent receives some percept, means there is some input coming from some sensor, and when the input comes, what it does, it try to update its state, because the agent has understanding that in what state I am. If this particular percept comes, then whether should I update my state or not. Therefore, update state function is called. There is some function that tells that what is my state, and it tells that what should be my state when I am into this state and I am getting this particular percept. Simple reflex kind of thing. And then it try to find out what sequence I should take. Okay, what sequence of actions I should take, because I told you that only taking action based on the current thing is not a good idea. You should see that what you are going to do into the future also. So you have to find out what is the sequence, and to find out that sequence, you first formulate using this, because you are into this state, you formulate the goal. Means what is your goal, whether you want to reach this particular place or what. So you formulate the goal, and then you get the goal, and using this goal and the current state, you see that what is the problem. You define the somebody is asking some question. Is this coded in Python language? No, this particular thing is pseudocode only. There is no Python over here. Formulate a problem, then since you know what is my current state, what is my goal, and then you use the formulate problem function that actually gives you the understanding of the problem, and then this problem is you send to some searching algorithm where you want to solve this particular problem, and then you solve this, and you get the sequence. Okay, So you then solve this thing to get the answer, and so then when you get the answer from this, because you have to get the solution sequence, so you know all the actions one by one what need to be taken. Then you take the first action that is there, that is the action, and the remaining you take into the sequence, and you take that, return that action, and that action has been taken. And when you take that action, what is going to happen? You again go to here, and you from here you again start the things, because when you are into the next state, you again do the computation to what to do into the next state. Because when you are into the next state, somebody else is going to also provide you some input. For example, when it is a game of chess, you estimated that these in the next 12 places you have to do these kind of moves, and you have taken the first move. But when in next time when the person gives goes for his own turn, he he forwards his things, then you have to again rethink, and you have to find out. It may be possible that you take the decision based on the earlier decision only, but again you have to reformulate the thing and think about what you are going to do into the next 11 steps, and you are going to take the first one only. So are you with me in this formulation? So you should know that the problem solving agent is actually based on the input that it is going to get. सामने वाले ने क्या चला, based on that he only formulate the problem, and then by one it try find out the solution, and only goes for the first move. And after first move, he again waits that let the other person do the things, let the environment send something so that it can take the appropriate action. Next action would be again then retune based on that. Is it clear? So I will be taking a 5-minute break over here. Any question, I would be keep taking the question. I am going to close the recording session. I would keep taking the questions with you, and